Welcome dear students. This is another video and unit 3 electrochemistry part. And in this we are going to discuss about the batteries. Until now we have covered what is electrode potential, Nernst equation, applications of electrochemical series and different types of electrodes. And now we are going to focus on the batteries. Battery is a device which contains more than two electrochemical cells connected in series and that can be used as a source of direct electric current. Simply say, there are a number of electrochemical cells arranged in series and based on the rechargeability capacity, based on whether the battery can be rechargeable or not, we classified the batteries into two categories, that is primary cells and secondary cells. Primary cells are non-rechargeable batteries. Secondary cells are rechargeable batteries. Why do primary cells are non-rechargeable? Because the chemical reaction is irreversible. Once the reactants are converted to products, we can't get back our reactants from the products. So as the cell reaction is irreversible, they can't be recharged. And once we use that, we should discard them. We can't use for a long period. We just have a short lifespan for the primary batteries. And they can be used as a storage battery also. And the best example is dry cell that we use every day for various applications. Whereas the secondary batteries are rechargeable batteries and in which the chemical reaction is reversible. Once the reactants are converted into products, the products can be get back to the reactant stage by supplying external electricity, so that we can consider they can be rechargeable and their lifespan is also more comparative to the primary batteries, and they can be used as an energy storage device. And lithium ion battery, lead acid battery, nickel cadmium battery, these are all comes under secondary batteries. Let's discuss the lead acid battery, in which the anode is lead and we take anode the sponge metallic lead, and cathode is also lead antimony alloys coated with lead dioxide, and the electrolyte that we use in these batteries are 20 to 21% dilute sulfuric acid. And they are all anode and cathode are arranged like this alternatively. Like if it is lead, you consider lead and these alternatively arranged like a with the lead oxide. And this is lead. So suppose this is lead oxide, lead oxide, lead oxide. They'll be arranged alternatively, and all the anodes will be connected to one terminal, and all the cathodes will be connected to another terminal. And in same thing here I just represented. So if you consider each lead is coated by means covered on both sides with lead dioxide, which is cathode, and which is dipped in the electrolytic solution. They are arranged in series. And here the picture shows us that 12 volts capacity battery where we have 6 electrochemical cells which contain lead and lead oxide with an electrolytic solution, and each are separated with an insulator inside and from one another also. They're all electrically connected but not directly in contact with each other. First, we'll start with the discharging. Here in secondary batteries, as I mentioned, the chemical reactions are reversible. So the forward reaction in which the reactants are converted to products is called discharging. Once all the reactants are converted into products, battery will run down and it needs to provide some external energy source, And when we are supplying energy from external source, the products will convert back into reactants. That process of reversible reaction is called charging. So I'm considering first the discharging reaction, where anode is lead and lead undergoes oxidation and it releases two electrons and Pb plus 2 ions. And these two electrons will move from through the external circuit towards the cathode, that is lead oxide, and where these Pb plus 2 ions will be released into the electrolytic solution, where in electrolyte we have sulfate anions that will combine with Pb plus 2 ions and produces PbSO4. This is the overall reaction at anode, that is lead reacts with the sulfate anion and we got PbSO4 and two electrons are released. As I told, these two electrons move towards the cathode and at cathode lead oxide and the H plus ions accepts the electrons and produces Pb plus 2 plus 2H2O. This Pb plus 2 again released into the electrolytic solution reacts with the sulfate anion and will get the lead sulfate. And here if you write the overall net reaction at cathode, this lead oxide plus 4H plus ion plus electron plus sulfate ion, we get 1 mole of PbSO4 and 2 moles of water. And if you can write the net reaction of the cell, discharge net reaction, combine these two reactions, what you'll get is lead plus lead oxide plus. You can observe here I have 1 mole of sulfate and here I have 1 mole. So I can mention 2 moles of sulfate ions and 2 electrons are released here at anode and 2 are accepted here. So these 2 will get cancelled. And what else we have? 4H plus ions. So 4H plus ions. Just ignore this, 2 electrons will not be here. And it gives 2 moles of PbSO4 plus 2 moles of water plus energy. And anode plus cathode, this 4H plus 2H2 2SO4 minus 2 I can write as 2H2SO4, means anode cathode electrolyte reacts and produces 2 moles of lead sulfate plus water plus energy. This is the discharging reaction. After some time, once all the lead and lead oxide got reacted, there is no more reactants, then we need to supply electricity from the external source so that the reversible reaction takes place. That's what mentioned as charging. So during the charging at anode, lead sulfate react with the water and releases the electrons. Along with that we got PbO2 plus 4H plus SO4 minus 2. And at cathode the electrons released from the external source, whatever we supply, accepts the electrons. PbSO4 accepts the electrons and produces lead and sulfate anions. So the net reaction is this. If you can observe, the discharging reaction is the products whatever you got here will be the reactants here, and the products are the reactants whatever we used in the discharging reaction. Means this is a reversible reaction. Forward reaction is discharging and the backward reaction is charging. And the application is, it is used in the automobile and construction equipment, and we do have backup for the system, and each single cell is of 2 volts. So depending on our capacity, generally in automobiles we use 12 volts battery, so which consists of 6 such type of cells. And the advantages are it's very low cost and ability to withstand even mistreatment also, and even it can perform well at high or low temperature conditions also. But it has a disadvantage, that is it has a low life cycle and it shows self discharging and low energy density also. And let's discuss about the various types of lithium cells. And lithium batteries comprises lithium as an anode, and lithium is used for various applications because it is the lightest of all metals, and its oxidation potential is very high, that is plus 0.305 volts, and it has high energy density. Because of these unique properties of lithium, we do have various applications in as a battery, and we have various types of lithium cells, and these lithium cells are primary cells, which can be of three types: solid cathode lithium cells, liquid cathode lithium cells, or solid electrolyte lithium cells. So let's start one type of lithium cell, that is a liquid cathode lithium cell. As I mentioned in previous earlier, that anode is always lithium. Just cathode varies from one electrode, one type of cell to the other type. Here, liquid cathode, we use liquid, that is thionyl chloride, as cathode, and the electrolyte is again a lithium aluminum chloride. And here the anodic reaction is simple, that 4 lithium ions releases 4 electrons and produces 4 Li plus. And at cathode, the thionyl chloride accepts the electrons in presence of 4 Li plus and produces LiCl plus SO2 plus sulfur. And the discharging voltage of this cell is 3.3 to 3.5 volts, and the energy density for this cell is 500 watts per kg. And we do use them in military and space applications, used in the medical devices such as neurosimulators, drug delivery systems. And these cells can also be used in electric circuit boards for supplying fixed voltage of memory protection. And we do have another type of lithium cells, that is solid cathode. Anode is same as the previous one, that is lithium cathode, but cathode is MnO2, and the electrolyte can be the lithium salt mixed in organic solvent. And generally we use 1,2-dimethoxyethane and propylene carbonate. And this anodic reaction is lithium produces lithium ion plus electrons, and at cathode the electrons will transfer towards the MnO2, which is a cathode, and Li plus involves in the reaction and will get MnO2 Li plus, or else I can mention it as LiMnO2. And this voltage is 3, and energy density is less compared with the liquid cathode lithium cells, which is 250 watts per kg. And these are used in the watches, calculator, and memory applications. Let's discuss about the lithium ion battery. Whatever we mentioned, we discussed previously, that is lithium cells or lithium batteries, which are non-rechargeable. But this lithium cell ion batteries are rechargeable, and they are portable batteries. Lithium ion moves from one electrode, positive electrode, to negative, negative to positive in these type of batteries. And lithium ion batteries use an intercalated lithium compound as one of the electrode material, and they possess a high energy density and low self-discharging capacity. And here the anode is graphite intercalated with lithium, and cathode is metal oxide. Generally we take lithium cobalt or lithium magnesium oxide, and the electrolyte should again contain lithium, that we generally use lithium perchlorate or lithium hexafluorophosphate, which are non-aqueous. If you can observe, here we have initially this graphite anode which is taken, which is intercalated with the lithium, and during the charging, number of lithium ions will migrate. First we'll discuss the charging. So here at anode, we have number of lithium ions which will move towards the cathode, and during the discharging process the number of lithium ions will move reverse from anode to cathode and cathode to anode. And we are not sure that all the 100% ions which are present at cathode will move towards the anode during the charging process, or all the lithium ions will move from anode to the cathode during the discharging process. There will be simultaneous movement of electron in the external circuit too, but majorly we focus on the lithium ion movement. That is, lithium which is intercalated into the graphite releases lithium ions, and that lithium ions will move towards the cathode during the discharge process and produces lithium CO cobalt oxide. And during the charging, whatever the lithium ions which are there at cathode will come back to the anode. And these lithium ion batteries are rechargeable and portable. Batteries are less toxic and recycled, and most commonly used in for various home appliances, even gadgets also. Thank you. We'll discuss about the fuel cells in next video.